In this lesson, we're going to start talking about quadratic relations. As you might recall, quadratic relations are those that have an exponent of 2, and they take the form of a parabola when graphed. Well, there are at least 3 methods for converting from standard form, which is y equals ax squared plus bx plus c, to vertex form, which is y equals a bracket x minus h quantity squared plus k. And those 3 methods are called completing the square, partial factoring, and the shortcut method. Well, the first one is completing the square. When you're given a quadratic relation in standard form, what you want to do is factor a from the first 2 terms. Then we divide the coefficient of x in the resulting bracket by 2, and we make a point of remembering this number. We then square the number that we just got, and we take that number, the result we got in part C, and we add it and subtract it inside the bracket. We then distribute out that value, distribute it out of the bracket, the part that's being subtracted, we distribute it out, and then what we do is complete the square. So what does that look like in practice? Well, let's take a look. We're going to convert each of the following from standard form to vertex form by completing the square. We're then going to state the vertex and the direction of opening and draw a quick sketch of the parabola. We're going to do that for these 4 quadratic relations right here. Okay, so starting with the first one, we have y equals 3x squared minus 24x plus 46. So the first step is to factor a from the first 2 terms. So we factor 3 out of the first 2 terms. Okay, the second step is to divide the coefficient of x in the bracket by 2. And then to remember that number. Well, the coefficient of x in the bracket is negative 8. So we divide it by 2, and the result is negative 4. And we want to make a point of remembering that number. I put it in a heart. And then we get to step 3. We square the value obtained in part B. Well, the value that we obtained in part B was negative 4. We square it, and we get 16. Then we see that we add and subtract the value that we obtained inside the bracket. So we obtain the value 16, so we add it and subtract it inside the bracket. We take what we had here, add and subtract 16 inside the bracket. Then what we do is we distribute out that value from the bracket, the part being subtracted. So this negative 16 here, we're going to distribute it out of the bracket, but first we have to multiply it by 3, and it becomes negative 48. So it's now been distributed out of the bracket. And finally, what we do is we complete the square. Well, what does that mean? The resulting trinomial in this bracket will be a perfect square. And you'll recognize this number that we said to remember earlier, this negative 4. It's actually 3 times x minus 4, quantity squared. That's what this is. And then this minus 48 plus 46 becomes minus 2. The vertex is 4 comma negative 2, because if you remember, we change the sign of the value inside the bracket when it's in vertex form, and we leave this sign the same. So we get positive 4 as our x-coordinate, negative 2 as our y-coordinate. Okay, this is vertex form, and this is the vertex. The direction of opening is up because we have a positive number in front. Our a value is positive. So what does that look like when we graph it? Our vertex is at 4, negative 2. And we sketch up. If we want, we can get a point on either side of the vertex. So if x is 4, we know y is negative 2. If it's helpful, we can think that 1 square to the left and 1 square to the right of the vertex, we just go up 3 because the a value is positive 3. And that helps to give us a good graph. Okay? All right, our next question. Y equals negative 2x squared minus 8x minus 5. Well, we see that our lead coefficient is negative 2, so we factor it out from the first 2 terms. Negative 2 times x squared plus 4x will become negative 2x squared minus 8x minus 5. Or sorry, will become negative 2x squared minus 8x. And then that negative 5 was untouched. We take this 4, divide it by 2, we get 2. We remember that number. We then square it, we get 4, and we add and subtract that value inside the bracket. And we can then take negative 2, multiply it by negative 4 to become positive 8, and we then have an expression where we can complete the square. What we do is we say this trinomial is equal to x plus 2 quantity squared. Remember that value, that positive 2, shows itself in the final answer. And then plus 8 minus 5 becomes positive 3. The vertex is negative 2, positive 3, and the direction of opening is down because the a value is negative. To graph that, we simply go to the vertex of negative 2, positive 3, and for every if we go one square to the left and one square to the right, we go down 2 units. And then we can graph a quality sketch. Our next one is x squared plus 10x plus 27. Well, the lead coefficient is 1, so factoring that out, we just have x squared plus 10x remaining. We take this value, divide it by 2, we get 5. We square that 5 and we get 25. So now what we can do is add and subtract 25 from inside that bracket. And then we still have this plus 27 that's unaffected so far. We then distribute out that negative 25, but we have to remember to multiply it by the 1. So that actually doesn't change the value. Negative 25 plus 27 is outside the bracket. And then we complete the square. Well, this is x plus 5 quantity squared, because 5 was the number we were told to remember. Negative 25 plus 27 is 2, so our vertex is negative 5 comma 2, because we changed this is vertex form, but the vertex itself has a negative 5 and a positive 2. The direction of opening is up because the lead coefficient is positive. And when we go to graph that, we see that our vertex is at negative 5, positive 2, and if we go one square to the left and one square to the right, we see that we go up 1 square because our lead coefficient is 1. And finally, for the completing the square portion, we have the function y equals 1/2 x squared minus 2x plus 3. When we factor out 1/2 from the first two terms, we get x squared minus 4x, because negative 2 divided by 1/2 is negative 4. We then take this value and divide it by 2, which gives us negative 2. We remember that value. We square it, we get 4. We add and subtract the 4 inside the bracket. We leave the plus 3 alone. We then distribute out the negative 4, but first we have to multiply it by 1/2. So 1/2 times negative 4 is negative 2, and we have the positive 3. Then we complete the square. X squared minus 4x plus 4 is x minus 2 quantity squared. Negative 2 plus 3 is positive 1. So we have 1/2 x minus 2 squared plus 1. The vertex is positive 2, positive 1, and the direction of opening is up. So we go here to the point 2, 1. And then from the vertex, if we go one unit to the left and 1 unit to the right, we have to go up 1/2 a unit, because this is the lead coefficient is positive 1/2. Okay, this gets us to our second method of converting to vertex form, which is partial factoring. And what we're going to do here is, given the quadratic ax squared plus bx plus c, we're going to factor ax from the first two terms. When we use completing the square, we only factor a from the first two terms. But when we do partial factoring, we factor ax from the first two terms. We then ignore the constant term c, and we set each of the factors that results equal to 0 and solve for x. And these are going to be the x values that make the y value equal to c. In other words, I'll explain that when we do our first question. But what we're doing is we know that each of these x values have the same vertical value on the graph, so that means the axis of symmetry has to be halfway in between. So that's part C. The axis of symmetry is halfway in between the x values found in part B. And so what we do is we find the axis of symmetry by adding those two x values here and dividing by 2. And that gets us the y value of the vertex, and then we have the x value of the vertex and the y value of the vertex. The lead coefficient is still the same, and we can put the expression in vertex form. Let's see what that looks like when we do a question. Actually, we'll do 4 of them. We're going to convert each of these from standard form to vertex form by partial factoring. Then we're going to state the vertex and the direction of opening and draw a quick sketch of the graph. So we're given y equals 4x squared minus 24x plus 34, as well as these next three examples. So let's start with y equals 4x squared minus 24x plus 34. When we, first step is to factor ax from the first two terms. So I factor 4x from the first two terms, and I'm left with x minus 6. 4x times x minus 6 is 4x squared minus 24x. Now what I do is I ignore the constant term c and set each of these factors equal to 0. So I set 4x equal to 0, that means x is 0, and I set x minus 6 equal to 0, that means x equals 6. I set these equal to 0. I ignore the 34. Now, what I'm saying here is those are the x values that make the y value equal to c. What that means is when x is 0 or when x is 6, y will be 34 in this case. Since both an x value of 0 and an x value of 6 result in the same vertical value, the same y value, that means we know the axis of symmetry is halfway in between x equals 0 and x equals 6. And that's what we say in part C. So what we do is we plug the x value of the axis of symmetry in to get the y value of the vertex. So we say the axis of symmetry is halfway in between these numbers, add them and divide by 2, that gives us 3. That's the x value of the vertex. Plug that x value in to either this expression or this expression and find out what y equals. Y equals negative 2. Our vertex is at 3, negative 2. So our lead coefficient is 4, and our x value of the vertex is 3, and our y value is negative 2. So we have a 4 in front. We change that sign when putting it in vertex form. We leave that sign the same, and the parabola opens up because the lead coefficient is positive. So then we go to graph it. We have a vertex at 3, negative 2, and when we move 1 unit to the right or 1 unit to the left of the vertex, we go up 4 units because that's the lead coefficient. Okay, here's our next question. Y equals negative 3x squared minus 12x minus 13. When we factor negative 3x out of the first two terms, we're left with this expression right here. Set this equal to 0, and I get x equaling 0. Set this equal to 0, and I get x equaling negative 4. Add these two values and divide by 2, and we get negative 2. The x value of the vertex is negative 2. We take that x value and plug it in here to find out what y should equal. Y ends up equaling negative 1. We've got a vertex at negative 2, negative 1, and so we change the sign here when putting it in vertex form, but we leave the a value the same, the original lead coefficient, and our y value is on the end, negative 1, and our parabola opens down. So our vertex will be at negative 2, negative 1, opening down. There we go. For our next question, we have y equaling negative x squared plus 5x minus 6. I can factor negative 1x from the first two terms, and I get x minus 5 in this bracket. I then set this expression equal to 0 and this expression equal to 0. I get x equaling 0 or 5. I add those two together and divide by 2, and the x value of the vertex is now 5 halves. I take this x value of the vertex, I plug it in here, and I don't forget to subtract 6. And what happens is I find out that the y value of the vertex is 1/4. That means the vertex is at 5 halves, 1/4. I can then change the sign here and put it into the vertex form. So if it's positive 5 halves, I make it x minus 5 halves. I don't forget my original lead coefficient, which is still negative 1, and I don't forget to add 1/4. And since the lead coefficient is negative, I know the parabola opens down. So my vertex is at 5 halves, 1/4, and I know that if I go 1 unit to the left or 1 unit to the right of the vertex, I'll go down 1 unit because my lead coefficient is negative 1. And finally, we have y equals 1/4 x squared minus 2x plus 5. So what we do is we factor 1/4 x from the first two terms, leaving plus 5 alone. I then set this equal to 0 and this equal to 0, so x is 0 or x is 8. Then what I can do is add these two together and divide by 2. So I know the x value of my vertex is 4. I then take a value of 4 and I plug it into either here or here to determine what y equals, which is 1. My vertex is at 4, 1 with a lead coefficient of 1/4. And I put that into vertex form. I know my parabola opens up, and I can then draw a nice sketch. I know that if I go 1 unit to the left or 1 unit to the right of my vertex, I'll go up 1/4 of a unit. And finally, we get to what I call the shortcut method. When you're given an expression in standard form, y equals ax squared plus bx plus c, you know the x value of the vertex is going to be negative b over 2a. What we can then do is substitute that x value into the equation of the function to determine the y value of the vertex, and the lead coefficient remains the same. So we're going to use that method to convert each of these functions to vertex form, and then we're going to state the vertex, direction of opening, and draw a quick sketch. So the first example here, 2x squared minus 12x plus 16, the x value of the vertex is at negative b over 2a, so positive 12 over 2 times 2 is 3. I take this value here, I plug it back in to determine what the y value of the vertex is, and so I now know the vertex is at 3, negative 2. I then go to state it in vertex form, which means I change this sign in the bracket, make it x minus 3 squared, but I leave that sign the same, and the lead coefficient stays the same. Since the lead coefficient is positive, the parabola opens up, and I can draw a decent sketch. That my vertex is at 3, negative 2, and if I go 1 unit to the left or 1 unit to the right of that vertex, I'll be going up 2 units because that's the lead coefficient. Okay? If y equals negative 3x squared minus 6x minus 5, then I can say the x value of the vertex is at negative b over 2a, which becomes positive 6 over 2 times negative 3, which is negative 1. I take that negative 1 value, I plug it in for x, and I get a y value of negative 2. I now know my vertex, negative 1, negative 2. I leave the coefficient in front the same. I change the sign on that x coordinate when I put it back into standard form, and I now have it in standard form. Obviously, the parabola opens down because the lead coefficient is negative. And when I go to graph it, I have a vertex at negative 1, negative 2, which is right here. And if I go 1 unit to the left or 1 unit to the right, I have to go down 3 units. Couple more questions here. Y equals negative x squared plus 4x plus 2. Well, the x value of my vertex is at negative b over 2a, so it's negative 4 over 2 times negative 1, which is equal to 2. I take an x value of 2, I plug it in for y, and I get a y value of 6. My vertex is at 2, 6. I leave the lead coefficient to be negative 1. That becomes x minus 2 in the bracket, and positive 6. My parabola opens down because the lead coefficient is negative. And that's what the graph looks like. And finally, we have y equals negative 1/2 x squared plus 3x minus 5. I know the x coordinate of the vertex will be at negative b over 2a, which is negative 3 over 2 times negative 1/2. That ends up equaling 3. I take an x value of 3, I plug it in here, and I get a y value. After you do all that addition and get a common denominator, the y value is actually negative 1/2. So my vertex is at 3, negative 1/2. My lead coefficient is negative 1/2. The 3 becomes x minus 3 when I put it back into vertex form. And the parabola opens down, and specifically, it looks like that. I hope you enjoyed that lesson.